morning. Okay, so today's exercises, so this one, so rectangular slab is there. So these are the different operations we need to be performed in order to get this object. So we need to be performed like side milling. We need to be sequence. By sequence means there is a face mill, side mill. Okay, later this is a drilling. It is a drilling of this. That is a holes, random position, and after that it is a contour bore is given. And for these holes we need to make the chamfer. Chamfer is given. Okay, the chamfer is given for these all the holes. And apart from this, there is a chamfer is given. Chamfer for this at the for this main component. Chamfer we need to provide at the end. Okay, so different operations. Totally this is a 200 into 120 to the slab. Okay, this is about the exercise. We'll start with the software. Okay. So go for a file, select the new. Okay, so this is you already know this units in mm. So default this is you can select the by default for this one, or if you have any object, so you can select that one. This is a loading and unloading time is 60 seconds. So 60 is that is a loading and unloading time. So these are the extreme positions of the tool. Okay, let it be. Okay, this is a initial setup, work setup. So next is go for option draw. So the our exercise is so rectangle. This is a 200 into 120. So under the draw, select these shapes. Okay, in the shapes, select the rectangle. So here the length is 200. Okay, the breadth is 120. So there will be no any corner radius, no any angle rotation. Okay, so this is our rectangle. So center is 0, 0. Select enter. Okay, so this is a rectangle. And for this we need to be make the so these holes. That is a pattern. That is a point pattern. So go for a option draw. So under this, that is a point pattern. So point patterns are, this is a parallelogram. Okay, parallelogram. Select the parallelogram. You need to give the, so that is a requirements. So here what is the length of this? That is a parallel diagram. That is a point pattern. That is a 120 is given. Okay, there is a 120. Okay, here the this is the length is 120, width is 60, and number of holes is here it is 5, here it is 3. The length is, so that is a 120. So that is a width is 60. Okay, the number of holes along this length is 5, and along the width is 3. There will be no any, so there is a angle of side to be, there is a rotation, there will be no need of any, so angle of to be side. Okay, so parallelogram as this is look like a rectangle. Give okay. So this is a requirement of this, right? Here just you need to be in the before things, always the cursor will be at the center. We can choose anything here, but here the cursor is already, it has been at this end. Okay, so we need to be define this end. So what is the end of this? That is a, here it is a cursor is at the, so this point particularly. So we need to define this coordinate. So here it is. So what is the coordinate? This is a 40 mm is here, and here it is, this is a totally it is a 120 from this point to, so this center is 90. There is 120 minus 90 is 30. Okay, so from this is a 30. This is a y direction. So this is a negative minus 30, and here it is totally it is a 200. So center is 100. From this 100, so this is at the end is, that is a 40 is there. That is a 100 minus 40 is, that is a 60 we removed. Okay, 60 we need to be, so give this. Okay, that is a minus 60 and the minus 40 coordinate. Understood? So this is a center we have considered, right? So this is a center. From this it will be 100, and from this it will be 60. Okay, so if you give the x as minus 60, because in this coordinate both will be negative. Okay, this is a last quadrant in the this quadrant. So x will be minus 60 comma minus, that is a total it is a 90, right? So this is a 90 means, sorry, yeah, this is a 90, this is 120 minus 90 is 30, this is a 30 and this is a 40. 40 means 100 minus 40 is 60. This is not 40, this is 30. Okay, so this will got the exact position. So randomly we have two more holes. Okay, here is a one hole and here is a one hole. It is given as this is a 20 and this is 30. Okay, so this is from this point, but we need to be, this is an absolute coordinate system, we need to be considered from the center. Okay, so this is, there is a 20, 20 is there. From this x-axis 100 minus 20 is, that is a 80 is here, there is a minus 80, and this is a 60 is here, center. From the 60 it is 20 means 40. Okay, one hole. Select the option draw, go for point pattern, select the points on random. So one is what I told, that is a, here it is x is minus 80, comma, so this is x is 80 because this is from 100, 100 minus 20 is 180, and this is 120, under the 120, 60 is the center, half of that, 60 minus 20 is 40, minus 40. Okay, this we got. Similarly, one more hole is there here. So the option is here 20 and this is 30. So here it is 20. Same, there is a 100. So 100 minus 20 is 80, but it is a x is plus 80. And y is, center is, that is a 60. 120, half of that is 60. 60 minus 30 is, that is a same 30. So that is 100. So this is 100 minus 20 is 80. So this is 80 and this is 30. Both are plus, 80, comma 30. Okay, so we got this. Okay, these are the two random holes. So this completes our, this is a geometry. Okay, so this is the only thing we need to be make, and the remaining, so this is a chamfer and the contour bore, and this is a chamfer, everything that we are going to be providing the machining part. Okay, so this completes our geometry. Here no need to be define the part because this is a standard, this is standard shapes. Just go for option draw. Okay, define blank. So what is the maximum here? That is 200 is there, right? Half of this is a total 200 is there, half of is 100. So this is 100 and this is 120, right? And if you have any, so this it is difficult to find out the dimensions of this. So what you can do is select the contour. You have one more option, select the contour. Okay, select this. So it is total, it will give you the dimensions of that. So what you have to do is just increase by 5 mm. Understood? Select the draw, go for option draw, define blank. Under the define blank, select the contour, select this rectangle. It will give you the, so what are the extreme coordinates of that. So under the extreme coordinates, so what you have to do is just increase the 5 mm just for the measuring purpose. Okay. So what happens is, this is a 120, instead of that is a 200, this is a 210 by 130 slab will be there. Okay, so the blank thickness is, here it is totally it is a 30 required, so 5 mm extra, 35 for the facing operation. Z coordinate, Z is required is, this is a 30, that is the actual, so that at the bottom it is negative sign, that is a minus 30. Okay, so this is a slab, exactly it is similar to that one. So exactly you selected that one, so it is looking like that. Okay, otherwise you can go for option draw, define a blank. What you can give is, so like this, this is a 100, right? 105 and this is 65, same as it is, minus 105 and minus 65. Okay, so like this we have selected the contour now, so because of that it was appeared like that. Directly you can select, if you know the coordinates, directly you can give the 5 mm extra of that. Okay, so this defines the, it is a blank. So this will complete our geometry. Next go for machining. Under the machining, so first is, so as you already, so you have learned, so just I will go fast. So this is machining. Under the machining, this is the same operations, that is a facing, milling, under the milling, face mill, Select the new tool, face mill tool, that is a 3 were there, you can choose anyone. That is a round insert I'll take. So in between that medium sized tool you consider. Okay, select the contour. This is a outer side contour, that is a, so what, that is a raw material blank. Both select, roughing and finishing, both the operation. Surface, that is a clearance, Z surface it will be 0 work surface, and the material thickness we need to remove is 5 mm. So after the allowance, this is a 0.5 we need to be removed. Okay. So after that it will give asking. In the previous exercises we have selected this. We can select here also. No issues in that. Just it will change the position of the movement of the tool itself. Go for a machine. That completes the face mill. So this completes the, so that is a face mill. So go for machining. Under the machining milling, select the side mill. Select the tool. So here the side mill is done by the, that is the end mill tool. Select this one. Select the maximum one or 30 mm. So the selection will be depending upon the, so that is an operator, so which tool he has to be select. Okay, depending upon the metal removal rate or the what is the finishing he requires, depending upon that, so he will select that one. Okay, and if you select this very smaller one, what happens is it requires a maximum time. If you select the larger tool, it is a, again that will be a problem, so that it should be an optimum. Okay, 30 mm. Select the contour. So this we need to be, that is a, so okay, select this one. Select the machining point somewhere, anywhere in this. Yes, completely we require outer side. This is outside milling. Select the outside. So work surface, this is everything. Always it will be a, there is a 0 itself from this side while we machining. So this is the extra 5 mm we considered. What is the material depth? Completely the whole depth, right? Whole. Okay. Initially we have considered 35. Already 5 mm is removed in the face mill. So just if you give 30, so that is enough, but extra 5 mm as I told, just to in order to remove the, in order to, that is remove any debris or the any parts which has been attached at the bottom of this. Okay. So select here, that is a side mill also. This is a 0.5 for the side mill. Select this, give OK. Okay, this is completes the side mill. So next is go for a machine. There is a machining point of the holes, drill. So before selecting this, check the, so what is the hole depth? 10 mm with 20 mm depth. Okay. Select the new tool. Select the, under this, select the drill. Under the drill, twist drill. Twist drill. Select the 10 mm drill bit. Okay, 10 mm drill bit. Select this one. So which points? So these are the points, right? Okay, so these are the points we need to be machined. This is, you don't select these two. Why? Because this is a drill is, there is a hole required for this is, there is a 8 mm. It is a change. Okay, so this is okay, done. No need to be, so remove any holes. Okay, so what is the hole depth we require? 20. It is given in the problem. The exercise, there is this 20 mm depth. So deep 20. Okay, so this completes the drilling of that. Okay, so drilling is completed. Next again go for a machining hole drill. Why I have changed selected the one more is because for these two random holes we require 8 mm hole. Go for this option under the drill, twist drill. Select the eight mm. We require only 8 mm hole. Select the 8 mm. Okay, select this. Select the point to be machined. Only these two. Right? Random we have no these two. Done. No need to be omit any holes. So what is the depth we require? See. So what is the depth? This is a whole depth, right? See here. From the top to bottom. The whole, it is a through hole is there. So that you can take more than 30 also. There will be no any changes in that. Okay. Let it be 32 or 35. Okay. Just if it is more than that, what happens is at the bottom exactly what happens is circular will be required. Tip will be having around. So see here. Around it will be having the, so if it is 30, so 30 will be here. Okay, in the remaining it will be here. What happens is sometimes the debris will be collected at the bottom. Okay, if it is a through hole, you can choose more than that. What happens is through hole, you will get the completely cylindrical hole. So after that, so what is extra is, that is a, here it is we require contour bore. So having a diameter of 120 for depth of 10 mm. select the machine under this hole, select the diameter, select the new tool, go for option twist drill. So it is a 12 mm hole, right? dia, okay, selected 12 mm dia. So what are the two, that is the holes, these two holes, select that, done. Now so what is the work surface depth is required is 10 mm, okay. Here it will be completely cylinder, so there will be no any problem for this tip at this, in this case, okay. So 10 mm, that is enough. So this completes the, so here it is, that is a contour boring, and the remaining is, that is a machining, and at the milling go for option chamfer, okay. That is a chamfer, select the new tool. So what you have given is, that is a 1 mm chamfer on this one side, okay. Chamfer of 60 mm, you select this 60 degree, right? You can select the this 16 mm dia or 18 mm chamfer, that is angle is 60 mm, that is we require. Select this, okay. Select the contour. So what are the contour we need to be, so this is a contour, right? Chamfer we need to make this, okay. For this contour, select the machining starting point anywhere here, okay. Yes, this is outside chamfer, right? Outside circle. So work surface Z, because this is a from this surface only, right? This is will be 0, okay. It will be 0 itself. What is the chamfer distance? So that is given is, this is chamfer for the whole the part, right? So this is here, the chamfer is not that one, this chamfer. So this is chamfer for the, so this completely part, that is, so 3 into 45 degree, right? 3 into 45 degree. Select the machine, that is a chamfer. Under the chamfer, select the new tool. This is 20 mm with 45 degree. This is given as 45 degree, okay. Select this, select the contour. This is a contour. Specify anywhere here. Yes, outer side. Okay. So this is a chamfer. Work surface is Z0. The distance is, in the problem it is given as 3 mm. 3 mm into 45. Select the 3 mm. Okay. So that completes the chamfer of this. And one more remaining is chamfering of these holes. Go for machine. So under the hole, that is the chamfer is nothing but, here it is the option called as, that is like a, so counter sinking, okay. Chamfering, it will provide like a conical shape of that. So that is a counter sinking. Select the counter sinking. Select the tool. Counter sink, here it is counter sink, okay. Select the counter sink. So here what is given here, so counter sinking is 1 into 60 degree chamfer, right? So here it is the chamfering, so maximum it can give, that is a 90, and it can give you the 120 of that, okay. So that is a, so here the contour, in this case they are not given, they are not provided the 60 mm. 60 degree hole is not, tool is not there. 60 chamfer it is requires, 60 is not there, you can edit this, okay. So nose radius is 90 is there, we want 60 nose radius, okay. Minimum diameter is 1.3, there is a maximum is 4.3, okay. In between that we can go for any one, okay. But here you need to check this. So what is the requirement of this? 1 mm is there. So already this hole is 10 mm, right? So this is a 10 mm hole. So 1 mm chamfer is for this side, 1 mm for this. Total what happens? This is 10 mm plus 1 plus 1, 12, right? Okay. Select the maximum. Okay. Okay. So here change this. That is for the 60 nose radius. Select this. Okay. Give OK. Select the point to be measured. These the completely point patterns of this. Okay. Select done. Okay. Do you want any omit holes? No. So this is what we require, okay. So selected the, what is the chamfer diameter now? So here this is already 10 plus 1 plus 1, that will be a 12 mm, okay. So this will be, we need to provide, okay. Select OK. So this completes your, that is a counter sinking, that is the chamfering for the holes. So next is the, so this tool path, okay. Let me see the tool path of this. So this is a change tool direction. In the previous exercise, this is from right side to left. Now it is from the left to right because of the selection of the, that is a tool direction. and this is the automatically it will generate the, so you can see there is a program, so for the geometry created, so what the geometry we created, no? So that will be done this the caps mill and capstone. So this is a drilling, and this is a okay, this is chamfer. Okay, understood. This is a previously done the drilling, so later this is a counter sinking, and this is drilling for the 8 mm hole and the boring. You can see the changing in the diameter, right? In the bottom it is a, there is a minimum diameter, and on the top of that is a maximum diameter, and this is the chamfering for the part, whole part. Okay, and the remaining documents you can see in the documents, power graph. Okay, see similarly you can see the time study sheet. In this you can see everything details, like what are the different operations we did and what are the complete details about that, with the each and everything, cutting speed, feed, tool number, feed rate, cutting, that is a total cutting length, total time required, so what is the rapid time, total time, everything, the total, that is a cycle time, this is a 88 minutes. Okay, that will be, it can be seen in the these documents. Similarly you can also see the tool list. What are the different tools we used for the this component? Okay, with the numbers, so exactly the what the, that is the dimensions we have selected, everything that will be, so it will be provided in this. Okay, this is about the, so this component. Okay, so thank you.